In this problem, we're going to solve an application involving normal distributions. Take a moment to pause the video to read all of its parts. So one thing you'll notice is I've already grabbed an image of a normal curve with 3 standard deviations marked to the left and to the right of the center. The center value here is the mean, so I'm going to go ahead and mark the mean value, which we're given to be 65, here on the x-axis. And I'm also going to mark the other remaining values of these tick marks using the standard deviation as a way to count. Think of it kind of like skip counting. You know, if you were labeling a number line, we're counting by 20s. So from 65, I'm going to add 20 to get 85, add 20 to get 105, and add 20 to get 125. I do the same thing in the other direction, but I subtract 20 to get 45, subtract 20 to get 25, and subtract 20 to get 5. So at that point, our normal curve is labeled with its mean and standard deviation. I knew to do this again because I see words like normally distributed and 68, 95, 99.7 rule. So those are some key words that clue you in to drawing this curve and labeling that x-axis. So next we're asked to find the relative frequency of rates less than 105 using this rule. So less than 105, that would be at this mark and anything below. Poorly drawn shading right here, but at that mark I am 2 standard deviations away. So the second number in that rule, 2, second number in that rule, tells me something related to this mark. So I'm going to draw this in a different color. But what it gives me is this area, or frequency, or relative frequency, I should say, under the curve. So just what you see here shaded in blue is the 95%. But there's a little bit more that I need over here on this side. So here's where I use some geometry and symmetry to figure out the rest of the problem. So if 95% is in blue, what's left, which would be this tail and this tail, together are 5%. But if I want to label them each separately, I need to divide that in half. So this tail on the right side would be 2.5%. This tail on the left side would be 2.5%. And ultimately, what I was asked to find was everything less than 105. So again, that was all of this region, the 95%, and this region, the 2.5%. So altogether, I do 95 plus 2.5% to get 97.5%. Now notice that they're asking this as a relative frequency or of rates. So instead of writing this as a percentage, we'll write it in its decimal form. So move that decimal 2 places, and that's how we get 0.975. All right, so now I've wiped the slate clean for a new problem, but yet using the same information. So I didn't change the x-axis, but what's changing here is the area that I'm looking for. So this one's asking for the relative frequency of rates greater than 85. So here is that 85 mark, and I want everything greater than that. All right, the 85 mark is 1 standard deviation away from the mean. So when I refer to this rule, I'm using the first number in that rule. But the first number in this rule tells me the area within 1 standard deviation of the mean. So it's actually given me this piece here in green, that this is 68%. So again, let's use some geometry and some symmetry to find what's left in red. So what we could do is say, okay, if that 68% is what's here in the middle, and the entire curve is 100%, let's do 100% minus 68% to see what's left. And what's left is 32%. That 32% represents together both tails on the left and the right. But we only want the right side of the tail, and because this image is symmetric, these two pieces are equal. So we're going to take 32% and divide it by 2 to get that just this region here on the right is 16%. Now it turns out that also this region is 16%, but we just need this region over here, the 16%. Again, since they're asking for it as a relative frequency, write that as a decimal value. All right, so again, I've wiped the slate clean, but I did not change the x-axis because that's related to the same values that we had before. But I do see where I accidentally erased a little bit too much. Let me fix that. Okay, so in part C, we're asked to find the relative frequency of rates between 25 and 65. So just this area between 25 and 65. So again, one of the first things I want to do is see how far am I from the mean in terms of standard deviations. That's 1, 2 standard deviations away. So I go to the 1, 2, the second number in that rule, and the second number in that rule, let me use a different color here. The second number in that rule says that within 2 standard deviations of the mean, what we have here is 95%, all in green. But we only want half of that to get this red region. So if we take 95% and divide that by 2, we have 47.5%. Again, because it's asking for relative frequency, we'll move that decimal 2 places and write it in its decimal form instead of its percent form.